Okay, I disagree with the answer scheme. So I'm going to redo it again with you guys. So first one is very simple, like we say just now, because you are looking at the force. So we have two equations. Okay, this one is W equals to delta K, which is the work energy theorem. Okay, this is our work energy theorem. Another one is work done by gravity. All right, so if you apply work done by gravity, then we have W equals to negative delta U. Okay, so the first questions, in a smooth pulley system, a force is required to bring an object of mass 5 kg to a height 20 meter at a constant speed. So it's going up at a constant speed. So we have a tensions, and then tensions on the other side. Okay, it's same as the first tensions because they are coming from the same string. Okay, same strings. So in order to calculate the force, the F, what are we going to do? We just apply Newton's first law. Okay, because of constant speed. So therefore, we have F minus W, which is equals to 0. F equals to W equals to mg, which is then equals to 49.1 Newton. All right, so this is the diagram that we have. So the second things that we're going to look at is the work done by the force. Okay, so work done by the force is equivalent to the work done in a tension. All right, so if we are going to apply equations W equals to Fs cos theta, then we look at what happens in the tension. All right, which is then equals to 49.1, and then the displacement given is 20 meter, and then cos is 0 degree. Okay, it's 0 degree, not 180, because now you're looking at what happens in the tension. Okay, the work done by tension is actually equals to the work done by this external force. All right, because on the other side, the displacement is going down. Therefore, okay, therefore the directions of movement and the directions of force, they are pointing towards the same direction. It should be 0 degree. All right, so you are going to obtain 982 joule. All right, now if you apply work done by gravitational force, all right, which is W equals to negative, negative delta U, then what are we going to have is negative, again, mgh final minus mgh initial. H initial, we take it as ground, which is H equals to 0. And then H final is 20. All right, therefore, this mgh initial, you can actually cancel it out and write it as 0, which then give you negative 5 kg, 9.81, and then the height is 20 meter. All right, and now which then give you negative 982 joule. Now this negative 982 joule, it is not our final answer yet. Okay, why? This one is actually the equation for work done by gravitational force. Okay, work done by gravity. Okay, work done by gravity is actually work done by this weight. So if you want to calculate work done by F, okay, work done by F, it is equals to negative work done by gravity. All right, therefore work done by F is actually equals to 982 joule. So it should be a positive value. All right, it should be a positive value, but not a negative value. So that is the answer for questions 1. Okay, so I give you 1 minute to write it down. Then if you got any questions, then you may ask. All right, this is the work done on the system. So this tension is doing the works. It is bringing the object up. So this is what we call work done on the system. All right, work done by the system is caused by the weight. Okay, it is happening because of the object's weight itself, the mass of the object itself. So W, we got a negative because this is the work done by the system. Okay, by the system. Okay, by the system. And then what we are looking at right now is the work done on the system. Okay, by the external factor. So the external factor is actually the tension. Okay, it's not happening inside, within the object itself. So this is the correct answer, not the one with the negative value. All right. So I give you 1 minute to write it down. If you got any questions, then you may ask.
Madam,
Yes?
boleh tak Madam repeat kenapa dia cos 0 degree?
Okay, cos 0 degree, because theta, actually we're looking at the angles between F and S. Okay, and now what we're looking at is actually on the left hand side. Okay, kita tengok part ini. Okay, kita tengok part ini. So part ini, if you look at this part, now your force is going downwards, and then the S, okay, or the V, the directions of motion is also going down. So you cannot look at it as one whole item, okay, as one whole object. You need to split it into left hand side and right hand side. So force is happening on the left hand side. So we look at what happens on the left hand side. On left hand side, force going down, and then displacement also going down. Both of them, they are heading towards same direction. Therefore, it is 0 degree. Okay? So boleh faham?
Faham? Terima kasih.
Bagus. Okay, so kalau siapa ada soalan lagi, boleh tanya. All right, now let's look at questions 2. Question 2, a stationary object of mass 3 kg is pulled upwards by a constant force of magnitude 50 Newton. Okay, so it has an external force, 50 Newton, and then determine the speed of the object when it travels upwards through 4 meter. All right, so now your object moving up by 4 meter. So what you have is the force, and then your force equals to 50 Newton. And then you have a S equals to 4 meter. And then you have a mass equals to 3 kg. So this is what I like to do when I go through the questions. All right, I want to go through the questions. I like to extract the informations at the same time, so that I know what is the information that I have, which variables that I have right now, which equations can be used. So initially, the object is at rest. How do I know? Because the questions mention stationary object. Okay, stationary object that is not moving. So I have U equals to 0 ms negative 1. So what happened? Now it wants us to determine the speed of the object, okay, which is your V. What is the values of the V? So now what are we going to do? Okay, now what are we going to do? All right, our object is moving up. Try to recall what is the equations that we have. Okay, now we have a U, we have V. Okay, and now we have S. This F, well, can we use it or not? Try to recall what is work energy theorem. Work energy theorem is W equals to delta K, right? But if you recall the definition for this work, okay, this works actually, it is the work done by net force, which means you cannot use this 50. This 50 is not net force, okay? It's not net force, but what it is external force, okay? It is external force. So which means now our main task is to find out what is the values of net force first. Okay, so total F summations F is equals to, according to my diagram, now I have an object. Okay, this object has an external force that is bringing it upwards. And since it is an object, every object, it comes with weight. So you have a weight that is going down. Therefore, I have F minus W. Okay, F minus W. So which is then equals to 50 minus mg. My m is 3, g is 9.81. Therefore, it is equals to 20.6 Newton. So this is our net force. Okay, this is net force. So from net force, we can then calculate the work done. Okay, then from there we can then determine the final velocity. So W, okay, I'm going to write it here. W equals to delta K. W at the same time, it is equals to F net. Okay, F net S equals to 1 over 2 mv squared minus 1 over 2 mu squared. How do I know it's V minus U? Because change in kinetic energy means K final minus K initial. From here, then we can solve the questions. So net force is 20.6 times with the displacement, which is a 4 meter. It is equals to 1 over 2. Now my mass is 3 kg, V squared minus, okay, minus what? Minus 0. Because my object initially is at rest. So from here, I then obtain V equals to 7.41 ms negative 1. Okay, 7.41 ms negative 1. So this is how we apply work energy theorem. We look at what happens to the kinetic energy. Okay, we ignore the potential energy, gravitational potential energy, we don't need it. Elastic potential energy, we don't look at it. We just focus on what happens in kinetic energy. The change in kinetic energy is equals to total work done, okay, or work done by net force. So make sure you know which work done to be used in these equations. You cannot just look at work done by a one component of the force, okay, by a component. No, you are going to look at net force. So in these questions, we have two components. One component is the external force, F. The other one is the weight. Therefore, you need to add an additional step to find out what is the values of net force. All right. So remember, when it comes to work energy theorem, the most important thing is the work done. Work done must be coming from net force. Okay, you must calculate it by using net force, not by any component of the force. All right, is that clear? So again, I give you 1 minute to write it down. So questions 1 is about work done by gravitational force. Questions 2 is work done by net force. We are looking at work energy theorem. So the first question is just by one component of force. The second question is the total force, okay, the resultant force. All right, so that is the main difference between W delta K and W delta U. All right, W delta K is net force. W delta U is just gravitational force. Okay, so setakat ini okay kan? Dia tak susah sangat lagi. Yang penting, okay, the most important thing is you know what is the difference between W equals delta K, W equals to delta U, W equals to Fs. Fs cos theta. Okay, Fs cos theta, you can have it for work done by component or work done by net force. But when it comes to delta K, it must be net force. When it comes to delta U, it must be gravitational force. Okay, now let's look at these questions. Questions number 3. A block of mass 2 kg, it slides 0.75 meter down an inclined plane that the slopes downwards at an angle 36.9 degree below horizontal. And then if the block starts from rest, okay, calculate the final speed. So what is the information that we have right now? Okay, again, we have this diagram. And now try to recall what is the force that causes our object to slide down. All right, so this object, now if you look at this question, it asks you to ignore friction, okay, which means the only force that we have in our diagram is just mg and n, okay? And the force that causes my object to slide down, if you look at this diagram carefully, is actually, okay, if you resolve W, the M, the weight, sorry. So you have a WY, and this is your WX. So the force that is causing my object to slide down is actually just the weight along its X component, okay? Along the X component. So which means, okay, our F net summations F in this case is equals to, okay, summations Fx is equals to mg, okay, mg cos or sine. Now you look at the angles. Angles 36.9 degree, it is located beside y component, 36.9. Therefore, I'm going to use sine theta, okay, mg sine theta, which is then equals to 2 kg 9.81 sine 36.9 degree, which is then equals to 11.8 Newton. So how do I know that I need the net force? Because now we want to calculate final speed. When it involves final speed, usually it involves kinetic energy. So in which it means we are going to apply work energy theorem again. So W equals to delta K. W is your F net. Okay, F net times S. Cos theta equals to K final minus K initial. So F net we have 11.8 times with the S. Now it tells you it slides down 0.75 meter. Okay, that is our S. So 0.75, and then cos usually is 0 degree unless it involves friction. Okay, equals to 1 over 2. Now mv squared minus 1 over 2 mu squared. Again, if you look at this question, it tells you now your object starts from rest. Start from rest, it tells you you can ignore this one. This is equals to 0. All right. Therefore, by rearranging the equations, we have V equals to 2.98 m as negative 1. So that's it. Okay, there's no complicated calculations here. As long as you know how to calculate work done is a Fs cos theta, where the F is coming from net force. Okay, so that is the only part that you need to resolve that involves sine and cos theta. When it comes to kinetic energy, the directions of motion is not important. Okay, and then so whether it is on a flat surface, on a horizontal plane, vertical planes, inclined plane, it doesn't matter. When it comes to energy, if you recall, energy is a scalar quantity, all right? Which means it only cares about its final and initial position, regardless of its directions of motions, regardless of where it is, how you place it, it doesn't matter, all right? It doesn't matter. You look at what happens at the first point, the initial point, and what happens at the final point, all right? So again, I give you 2 minutes to write it down.
Hello.
Wait, yeah, you guys write down the answer first. I got a call, incoming call. Okay, yes, Govin. What is the questions?
How do you know the angle is at 36.9 degree below? I mean, like, how do you actually picturize where the angle is?
Well, because this is a triangle, right? Now, if you look at this weight, if you extrapolate it, it's actually forming a right angle triangle. So now you have a right angle triangle here, where this is 36.9 degree, which tells you here would be a 53.1 degree, right? So in between x and y component, this is 90 degree. It forms a 90 degree here. So you use 90 degrees, subtract this 53.1, it gives you 36.9 degree beside y component. You get what I mean?
Since it's below horizontal, so that's why you minus with 90 degree with 53.1 degree. Is that how it works?
Huh? Sorry?
Like how do you know, like, okay, say 53.1 degree is actually where in our free body diagram? It's
No,
actually
because the 36.9 degree is given in the diagram.
okay. So then now we have formed the right angle triangle. So 90, 36.9, then 53.1. But then
Yeah,
this 53.1, where is it actually? Is it
that is your x component. Because if you look at
oh,
this diagram, your weight, the slope surface, the inclined surface, and the horizontal plane is actually forming a right angle triangle here.
so
So,
that's when you minus with 90. Okay.
because one triangle, the total angles inside is 180 degrees. So this is right angle triangle, you minus 90, and then you minus another 36.9, which give you this part is actually equals to 53.1. 53.1 is the angle beside x component. If you want to use this 53.1, that is fine. You go ahead, but then you have to change this part into cos 53.1. Okay, cos 53.1. So, but usually we will just take 36.9 because straight away we know it is the angles beside y component. Okay, because when you have a right angle triangles here, okay, this is your right angle triangle, it gives you 90 degree. So 90 minus 53.1, it give you back 36.9 beside y component. So straight away, you don't even have to calculate the 53.1. Whenever you have the angle 36.9 or the angles for this inclined plane, then you know this angle is definitely equal to the angle beside y component.
okay.
Exactly. All
It's
right.
clear. I got the picture already.
Yeah. All right. Okay, now questions 4. Questions 4, an object of mass 2 kg moving along the x-axis and is acted on by a force. Okay, figure above shows how force varies with distance traveled. So distance traveled with the force, and then the speed of the object as equals to 0 is the speed of the object at s equals to 0 is a 10 meter per second. Okay, it's 10 meter per second. So initial, okay, this is your initial velocity u. Okay, so you have m. Okay, now what do you have? So it wants you to calculate the speed of the object as 10, s equals to 10 meter. Now it wants you to calculate the final, okay, the final velocity. So what do we want? Now you have a graph. When you have an fs graph, okay, what do you have? You can actually calculate the total work done. Why? Because W total is equals to area under the graph. All right, area under the graph. So again, this is under fs graph. All right, to be more precise, we are going to make it more precise. So it should be under fs graph. So this statement itself, you need to include in your answer, okay, in an objective paper, because it's 1 mark. It represents concept, okay, it represents concept. So how are we going to calculate it? Now you look at this diagram, okay, you actually have 2 trapezium. 1 positive work done and 1 negative work done. So this is your total work done. So it is equals to, now let's calculate the work done for the first area, for the positive area. So 1 over 2, so base is a 6, 6 plus upper side is 4 times with the height of the trapezium, which is 10, and then plus 1 over 2, now the base, okay, this one from 6 until 10, this is 4, this is 3. So 4 plus 3 times with the height, which is negative 5. You need to include the negative sign. All right, which then give you 32.5 joule. Okay, 32.5 joule. So now you want to calculate final speed, okay, which is the final velocity. So what are you going to do? Again, try to recall what is the equations that can link velocity and work done together. Obviously, it is our work energy theorem. So work energy theorems, once again, we have W equals to delta K. Okay, so our W now, we have the values already, which is 32.5 equals to 1 over 2. Now my M is 2V squared, again minus, okay, now it's not minus 0 now, all right? Because now you have a non-zero initial velocity. So 1 over 2, 2, and then 10 squared. Rearrange the equations. You will obtain V equals to 11.5 ms negative 1. Okay, 11.5 ms negative 1. So that is questions 8. It's very simple. You just want to see whether you know how to extract the information from the graph and whether you understand what types of information that you are getting from the graph. So the information that you obtain from the graph is the total work done. It's the work done by net force. Okay, it is already the work done by net force. Therefore, you can straight away apply it in our work energy theorem. Right? Okay, so next. The kinetic energy of the object at 6 meter, okay, S equals to 6 meter, which tell us once the, okay, it wants the graph until 6 meter only, okay, so it wants the information it wants is until this point. So what's the questions 2.1 is just this part, okay, the first trapezium. So we are going to ignore the second trapezium. So what are we going to do now? Again, we're going to calculate the total work done first. So W equals to trapezium is 1 over 2. The first trapezium is a 6 plus 4 times 10. All right, which then gives us 50 joule. So from here, we then apply work energy theorem. But now the difference is because the question is asking for kinetic energy. So you don't calculate final velocity. Okay, so 50 equals to K in final minus K initial, which is 1 over 2 times 10 squared. Okay, which is then equals to 150 joule. All right, so be careful. This question is a bit tricky. Question 1 is asking for final velocity, and questions 2 is asking for kinetic energy. Okay, final kinetic energy rather than initial kinetic energy. All right, so that is our questions 4. Okay, so very simple. It's only a bit tricky because of this part. Okay, kinetic energy. So you expand one and then you leave the other one as K. Okay, so it's actually K final minus K initial equals to K final minus 1 over 2 mu squared. Right, so you expand one and then you keep one in terms of K. All right, so now we have these questions done. Okay, questions 4. So again, I give you some time to write it down. So if you have any questions that you don't understand, make sure to ask now. Okay, work energy theorem, students just confuse that, or I would rather say students, they don't understand that work energy theorem actually involves just the kinetic energy. Okay, it doesn't involve all the other sort of energy except kinetic energy, because according to the definition itself, the change in kinetic energy is equals to total work done. All right, so even though when an object is moving, maybe it involves various types of energy, but the one that we're looking at is just what happened in its kinetic energy. Okay, in its kinetic energy. Okay, so we're going to take 5, and then after 5 minutes, I will continue with the last subtopic, which is power. Okay, so hopefully we can finish in another half an hour. So 5 minutes break. After that, we'll continue with the power. All right, let us continue the last part in chapter 5. Then next week, if we got class, then we can proceed to chapter 6. Okay. So chapter 6, you can also try it because I think basically we have done discussing all the possible cases in a lecture already. All right, you tried it, then we can go through for much faster. Okay, now exercise 5. A stationary car of mass. Now you have mass. Why is it not coming out? Okay. So a stationary car of mass 1000 kg, it starts to accelerate at a constant rate. And then it reaches a speed of 10 meter per second in 8 seconds. So initially you have a stationary car, which tells you U is equal to 0. And then you have a V, and then you have a T, right? So determines the work done on the car in this time interval. Work done on the car in this time interval. Now you want to calculate work done. Okay, so apparently we know that work done, W equals to F dot S cos theta. But if you look at these questions, we don't have enough information. So this is not our choice of equations. Now what do we have? We have velocity. So if we have velocity, what does it mean? It means we can try it out, work energy theorem, see whether we can get an answer or not. So W equals to delta K, which is equals to K final minus K initial. Then we have 1 over 2 mv squared minus 1 over 2 mu squared. Now let's see, do we have enough information? Well, we do, because we have m, we have v, and we have u. So you sub all of the informations into the equations. Okay, 1 over 2, 1000. So a 10 square minus 0. Okay, so because initial velocity, it starts from 0. So minus 0, it is then equals to 50 kilojoule. Okay, 50 kilojoule, or 50 times, or 5 times 10 to the power of 4. Okay, 5 times 10 to the power of 4 joule also can. Okay, also can. And then the next part, questions B. It asks us to calculate average power. Average power, we have just one equation, which is PAV equals to W over T. All right. So W is 50 kilojoule. So 50 times 10 to the power of 3 joule divided by times taken, which is 8 seconds. Then we can get 6.25 times 10 to the power of 3 watt. Okay, so don't get confused between work done and watt. Okay, this is the unit for power. Right? Questions A is work done. Questions B, the W represents unit for power. So that is the answer for questions 1. See, it's very simple actually. If you know how to extract the information from the questions, if you know how to select the equations. Okay. So 1 minute for you to write it down. Then we will look at the second questions. All right, now let's look at the next questions. A person of mass 50 kg, okay, runs up 200 meter. Okay, now this 200 meter is okay, so it runs up 200 meters up a straight incline. So now you have an incline plane. So the angles given is 20 degree. And then this is 200 meter, right? In a 50 seconds. So this is our S, and then this is the time. Okay, then theta given is 20 degree. So questions ask you to calculate the work done. Okay, the work done to runs. Okay, the work done to runs up. So if you look at this diagram, okay, now you have a person's running. Okay, but then we don't have any other informations already. We don't know whether the person is running with a constant rate or not. And then we don't know whether there's any external force or not. But what we do have is just the displacement and the angles. So what can we determine based on here? So we know that H initial is equal to 0. So from the triangles given, we can then calculate the H final, which is equals to 200 sine 20 degree. We can get the final height. All right. So in this case, we can then calculate the work done. All right. Now work done, W is equals to now, because you're running out, okay, and then there's a change in the potential energy. So therefore, W is equals to negative delta U, okay, which is then equals to negative mgh final minus mgh initial. So initial, straight away you can cross it out because it's a 0. And then you sub everything into the equation. Negative, the mass is 50 kg, 9.81, and then this one is equals to 200 sine 20 degree. Okay, the final answer is negative 33.6 times 10 to the power of 3 joule. So that is the answer. All right, that is the answer. So how do I know that I'm going to apply W equals negative delta U? Because now I have the change in height. And other than that, I don't have any other informations. I don't have the total force acting on the object. Okay, I don't know how many forces acting on my object right now. I don't know whether it's moving with a constant velocity or constant accelerations and so on. But what I do have is now is changing its position. Okay, so from H equals to 0 to H equals to 200 sine 20 degree. So from there, I can then determine the work done. All right, so work done equals to negative delta U. And therefore, the average power, once again, now you're looking at average. So P average is equals to W over T. Okay, which is then equals to 30.6 over 50. All right, which is equals to 0.67 kilowatt. Okay, 0.67 kilowatt. Okay, so remember, yeah, we don't have a negative power. We have positive power only. So you don't have to include the negative sign. Negative sign in work done, it just tells us whether it's work done on the system or work done by the system. Okay, questions number 3. Now we go back to graph. Okay, so an object is exerted by a force. Then it moves along a straight line. Figure above shows how the magnitude of the force varies with displacements of the object. Time taken to travel from S equals to 0 to S equals to 2 is 1.5 second. So this part is 1.5 second. And then for 2 to 4 is 2 second. Okay, 2 second. So determine the average power received by the object when it moved from S equals to 0 until S equals to 2 meter. So from 0 to 2 meter, the first thing that we need, okay, now if you recall average power, PAV is equals to W over T, which means we need the work done. All right, we need the work done. So how to calculate work done? Now you're given the F against S graph. So W equals to area under Fs graph. So how are we going to calculate work done? We look at its displacement. Now the questions 1 is asking for displacement from 0 until 2. So it just wants the first part of the graph. First part of the graph is a triangle. Okay, therefore 1 over 2 times the base, which is 2, and then times the height. So work done is equals to 5 joule. So from here, we can then determine the average power. So W over T, which is a 5 over, now the time taken is 1.5 second from 0 until 2 meter. Okay, therefore it is equals to 3.3 watt. Right? So second questions, basically you just repeat the same thing, but now you're looking at the displacement from 2 to 4, which is the rectangular. So W equals to 2 times 5, which is equals to 10 joule. Right? So therefore, P average is equals to W over T equals to 10 divided by 2, because it's 2 seconds. Okay, from 2 meter until 4 meter is 2 seconds. So it is equals to 5 watt. Question C. Okay, question C, very simple. So work done, the whole work done, now you have the work done is a 5 joule from questions 1, 10 joule for questions B. So total work done, W equals to 5 plus 10, which is equals to 15 joule. All right, and then P average is equals to 15 over, now the whole journey, it takes up 3.5 seconds. So divided by 3.5, which is then equals to 4.3 watt. So it's very, very simple. All right, these questions. You just need to get the work done from the graph. And make sure you get the correct part of the graph. Okay, you calculate the correct part of the graph. Okay, so 1 minute for you to write it down, then we are almost done. Okay. So last question is just a very simple questions. A car with a powers, now you are given the power, okay? It doesn't want you to calculate powers. So it produces a constant force, okay, which is your force, F. Then calculate the velocity of the car. So you want V. So obviously you see PFV straight away. P is equals to FV. Okay, so 100 kilowatt, 100 times 10 to the power of 3 equals to 500 V. So V is then equals to 200 meter per second. So done. Okay, and story. This is very simple. You just calculate the instantaneous velocity of the car when the power is 100 kilowatt. Okay, when the power is 100 kilowatt. So that marks the end of today's class. Okay, if you have any questions, you may ask. If no, then you may leave the class. right? So thank you for attending the class. And then Monday, I will be doing chapter 6 with you guys. All right, so the lab, we pause first, on hold first. I'm going to finish chapter 6 first. Okay, so if no questions, then you may leave the class.
Thank you, Madam.